I think we all know what micro frontends are about. It's about splitting a huge application into tiny parts. Tiny parts that can be implemented by several more or less autarkic teams. And at the end of the day, this brings back the agility of a small team, even though you have a huge overall software system. And I think this clearly shows that micro frontends are first and foremost about scaling teams. If you just have one team, then perhaps you won't reach the sweet spot of micro frontends. But if you have several teams, if you want to make them to work in an autarkic way, then this could be a nice fit. However, there is an issue, an enemy, this guy here. Your customer, the guy with the money. Because the thing is, the end customer is not interested into micro front ends at all. No, not at all. They are just interested into one integrated application. One application that is capable of everything they need to do. And that means that somehow we need to integrate all those micro front ends into one whole thingy. And this needs to happen at runtime because all the teams work in an autarkic way. They implement their stuff in an autarkic way, they deploy it separately. And so we can only grab it at runtime and try to integrate it into something I would call a shell. However, the thing is, runtime integration is really difficult. It's really difficult, but nevertheless, there are several options for it. In the past years, several people worked with, I'm not sure if I'm allowed to say it, with iframes. Yeah, you would be promised how much huge companies are using iframes, but no one is talking about it. But a lot of companies are using it. On the other side, people try to integrate several different web components, which is a bit more a modern approach, but nevertheless, you need to write a lot of system level code to make this happen, a lot of infrastructure code. And that's not funny because most of us are paid for implementing use cases, real world business use cases, something like this. And that's why I'm really happy that for about 2 years, we have module federation. It ships with Webpack, and Webpack is a very common tool. It is used in all the communities. It has several 100 million downloads a week, so it's really a big number. And now it also gives us module federation. And basically, module federation allows us to load something from over there, to load a piece of a separately compiled and deployed application, an application that could be a micro frontend. So it's really a piece of cake, as you see here. And this is what I will talk about today. I want to show you how module federation works. And for this, I give you a little tiny primer, and then I will also show you an example that is sharing data and libraries. This is one of the big benefits of module federation, being capable of sharing data structures and libraries so that you don't need to download them twice or several times into all your micro frontends. Then we will proceed with dealing with version mismatches. Obviously, if we share libraries, we will have a version mismatch. This part might need version 10 of a library, that part might need version 11 of a library, and then somehow we need to resolve this conflict. And last but not least, I will talk about combining multiple frameworks and multiple framework versions, something like mixing and matching Angular with React and Vue. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm doing a lot of workshops and consultancy. I'm also quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the world, which quite nicely works nowadays because meanwhile we are all used to remote technologies. Okay, let's get started with the first chapter I've prepared for you. It's about module federation in general. So the thing is, when you go with module federation, you subdivide your application into two categories. The first category is officially called the host. It's our micro front-end shell, the shell that is capable of loading several micro front-ends into its working area. And the second category is the remote. In our case, it's the micro front-end itself, the micro front-end that's loaded on demand. Both roles can be configured with the Webpack configuration. For instance, when it comes to the shell, you could configure a virtual URL. A virtual URL, in this case, it's called MFE1, which stands for Micro Frontend 1. Yeah, I know it's not that creative. And you see here, it points over to another application, to an application deployed over there at this or that location, at this or that URL. And over there, I have my micro frontend, and this micro frontend can expose files. It can expose ECMAScript modules. That's why it's called module federation. In this case, my module is called my component.ts, and I'm exposing it under this short name. Normally, you are assigning a short alias when you expose a file because the shell is not interested into your folder structure. The shell is not interested that this or that file is located in A/B/B/C/something. No, we just want to go with a pretty name. That's why we go with an alias. And when you have done this, something beautiful happens. I guarantee you will love it. When you have done this, all you need is just a dynamic import, a ECMAScript standard dynamic import that is using the map names. And so you can point over there and grab something from this separately compiled and deployed application. And the best of this is your framework will not even recognize that something special is going on. Your framework, regardless if it is Angular, Vue, React, or something else, just sees a dynamic import. And so your framework assumes, yeah, something like lazy loading is going on. However, underneath the covers, it's far more than just traditionally lazy loading. Underneath the covers, it's grabbing something we did not know at compile time, something from the inner workings of a different application. But as your framework is not even recognizing this, you can use your framework as is. You don't need to tweak your framework. You don't need to go with any 30 workarounds. No, just use it as is and, Bob's your uncle. However, you can also make it a bit more dynamic. If you don't want to register all your remotes upfront, you can just clear this remote section here, and then you can tell module federation at runtime about all the micro frontends you want to load. This gives you the capability of, first of all, reading a configuration file that informs you at the startup time about this and that micro frontend available over here and over there. And then you can say, no, please just load it. You can instrument module federation at runtime. Normally, this takes a bit more code, very low level kind of code. Here I have just wrapped this low-level code into a helper function. It's a custom helper function telling Webpack to load this or that in a very dynamic way. One of the best things here is you can also share libraries. You could say, well, I'm using Angular here, you are using Angular there, so just let's load Angular once. It does not make sense to load Angular 10 times just because of having 10 micro frontends. No, let's just load it once and then let's share it. Of course, this will decrease the amount of bytes you need to download, and so this will also increase your performance, or at least improve your performance. When you want to go with Webpack, and if you are an Angular person like me, then first of all, you need to install a little tiny plugin, a plugin like this here. The reason for this is that Angular is shielding Webpack from us, which is kind of good and sometimes kind of bad. You don't get in touch with Webpack directly, so you need a plugin to activate module federation within Webpack. Then you also get a configuration file generated, and this configuration file needs to be adjusted to your needs. And then you serve your application, and if you haven't done any mistake, everything should work. If you are not using Angular, then normally you have direct access to your Webpack configuration. Or perhaps you can eject your Webpack configuration, which is, for instance, the case with Create React. And this means you just need to adjust this configuration file, start your application, and one more time, pops your uncle. Let me show you all of this in practice. For this, I have prepared a little tiny application, and I think I've opened it some minutes before, but let's reopen it. Yeah, here we go. This is my micro frontend. It's within those red dashed lines. And here we have my micro frontend shell. So two different applications. If you look a bit more closely, you will even recognize that those applications run on two different origins. We have two different ports. We have port 5000 here and port 3000 there. This is not a prerequisite, not at all. However, using different ports, using different servers really proves that we are talking about separately compiled and deployed applications. But no one prevents you from deploying everything on one server, perhaps in different subdirectories. And now, when I'm clicking here on flights, you see this micro frontend is seamlessly loaded into my shell. It's directly loaded into the working area of my application. No one really recognizes that we are talking about two separate applications. Nice, isn't it? So if we look at this a bit more closely, for instance, if we open the network tab, yeah, and if I reload this, then first of all, we see that only the stuff needed for the shell is loaded, which is some metadata we need for using the shell, and also some libraries we want to share. Everything we want to share is loaded via a separate bundle, like here, Angular Core, Angular Common, Angular Platform. If you are going with React, it would be React and React DOM, and so on and so forth. And then, when I'm clicking here, only the remaining parts for this little tiny micro frontends are loaded. In this case, it's about 20 Ks. If I would run this in production mode, it would be far less. So it's not a big deal. Everything else is shared, so we don't need to reload Angular. How cool is that? Now let's have a look into our source code. First of all, if we look into the folder structure of our source code, we see that we just have a traditional project. Here is my MFE1 project. It's a traditional Angular project. It could be a traditional React Vue Svelte or something else project. Business as usual, but you also have this Webpack configuration here. In my case, it's a partial Webpack configuration. You might have a fully fledged Webpack configuration. However, everything that matters is this little tiny configuration here. This little tiny configuration that tells Webpack how to behave in terms of module federation. If you have a fully fledged Webpack configuration, you would go with a module federation plugin, and this would be the configuration for this plugin. Here I have a helper function that is squeezing this configuration into Angular's overall Webpack configuration. And if we look a bit more closely here, we see three sections. We assign a unique name to our micro frontend. It's still MFE1. We define what to expose. This could be literally everything you have in your project. Everything that speaks ECMAScript can be exposed here. A function, a constant, just a string, an object, a class, it does not matter. In my case, I'm exporting or exposing a module, an Angular module, which is just a class with some metadata. And as you see here, this metadata defines some routes. Routes I can activate by clicking here, by clicking there. That means after loading this module, I can directly jump to routes of this very micro frontend. But at the end of the day, this can be everything that understands ECMAScript as mentioned. I'm assigning a little tiny alias like module, and then I'm telling Webpack to share everything. I want to share everything. I'm quite a generous person. And sharing everything is a good thing for getting started, because at the beginning, you don't know which libraries to share. So just share everything. It gives you a quick win. And then you can decide that you don't want to share this or that after you have a first running configuration. For this, I've written the share all helper. It is just a little tiny helper function that looks into my package JSON. It looks into the dependency section of my package JSON, and then it lists all those dependencies here in this shared object so that everything will be shared. And that's it. So at the end of the day, you add somehow this configuration, and this makes a micro frontend out of your traditional application. Let's move on. We have a similar configuration for the shell. This here is the configuration for the shell. It looks about the same, but we only have a shared section here. The thing is, sharing is always an opt-in thingy. If I want you to share your desert with me, I need to opt in. I'm not concerned about this, but also you need to opt in. Otherwise, it's not sharing. Otherwise, it's stealing. And we don't want anyone to steal our desert, because when it's about deserts, I don't have any humor left. And so we need to define at both sides that this and that library should be shared. And that's it. This little tiny configuration file makes also a shell out of our traditional application. When bootstrapping our application, I'm bootstrapping it within the main TS function. First of all, we need to initialize module federation. And for this, I have a helper function here that is loading a configuration file. I'm calling it the manifest, the module federation manifest. The manifest is really a simple JSON file. It just contains the short names pointing to our micro frontends and the URL where this micro frontend is located at. More precisely, it's not the URL of the micro frontend, it's the URL of the remote entry point of this micro frontend. So what's a remote entry point? Well, when we compile a micro frontend, Module Federation generates a remote entry file for us. And this is just a JavaScript file with some metadata about the micro frontend. Obviously, the shell needs to know a little thing about this and that micro frontend. It needs to know how to talk with it, where to find it, which dependencies to share with it. And that's why we need to load those metadata file here. So more or less, this is a configuration that is just mapping the name of the micro frontend to its remote entry file that is auto-generated by Module Federation. You don't need to have such a manifest. You could also hard code this in your source code, but I guess hard coding stuff like this is not the smartest decision, because normally those URLs will change. They will change You will have a different URL in production compared to development mode. Okay, so as mentioned, this file is loaded. This will initialize module federation, and then we need to import another file that is doing what our application is doing all the time, namely starting it up, bootstrapping it. We really need 2 different files for it. Otherwise, we would have an han-ack issue, because only after reading the metadata, we know that we want to share Angular and other libraries with this or that micro frontend. And only then we can bootstrap the application that loads the shared version of Angular or this or that micro frontend. Yeah, and the rest is just about routing. It depends a bit on your framework, but I'm quite sure the framework of choice has some capability of doing routing and lazy loading. Normally, when doing routing and lazy loading, you just go with an import, with a dynamic import. Instead, I have a little tiny helper function here that tells us, hey, look into the manifest, look up this micro frontend, it has a URL, use it, and load from over there something that's called /module. And as we all remember, over there, an Angular module is exposed under this name. And that's it. So from your application's perspective, it's just about lazy loading with a helper function. And of course, you need a configuration file and initialize module federation during the startup. However, I already hear you thinking, even though we are separated via Zoom, I heard you thinking that if we share libraries, we will end up with version mismatches. You know, it's quite common to migrate everything to the web. And perhaps you remember DLL hell. If you are a long-term Windows user, you will for sure remember DLL hell, where you had several DLLs in different versions and they had a conflict with each other. And now, with sharing libraries, we would more or less migrate DLL hell to the web too. And of course, migrating an issue like DLL hell to the web is not a good idea. And that's why I have a good message for you. Webpack comes with several strategies for dealing with such version mismatches. I'm not sure if you know it, but Webpack itself is German. Webpack itself is has been written by a guy. He's called Tobias Koppers, and he lives in Germany, in a northern area of Bavaria. Never ever call them Bavarians. They are Franconians, but if you look to the map, it's located in the north of Bavaria. And there, Tobias wrote a master thesis several years ago. And the master thesis was not about Webpack. No, it was about an application. Webpack was just a byproduct of this master thesis. A byproduct because somehow he needed to bundle his application. And this byproduct really became famous so that we have several 100,000 downloads a week nowadays, which is quite a number, isn't it? Yeah, I think it just appeared at the right moment in time, at the right place. And so a lot of people adopted it. And yeah, I think this was a good thing. It really filled the gap. However, to proceed with the story, Tobias had a first version of module federation about 3 years ago. Back then it was in beta. It was, by the way, a community contribution. And Tobias saw this implementation and figured out, hey, this implementation is great. However, he also figured out that he needed a better story for dealing with version mismatches, because this was a huge point of criticism from the community, especially if he talked with companies, with huge companies that told him that this might be a deal breaker. And yeah, so he rewrote module federation, and when rewriting it, he baked in strategies for dealing with version mismatches into Webpack module federation's DNA. And that means there are several possibilities to deal with it. And if you configure none of those possibilities, you get a very smart default behavior. The smart default behavior is about selecting the highest compatible version. Selecting the highest compatible version. I know this sounds a bit awkward, so let me give you an example for this. Let's assume we have one micro frontend with shared library version 10. And then we have another micro frontend with shared library version 10.1. Because of having the metadata, module federation knows, hey, here I have a newer version, and according to semantic versioning, it's even backwards compatible. You know, according to semantic versioning, if you just increase the minor version, it should be backwards compatible. And that's why by default, module federation will decide to just load this very version. It won't load version 10. Quite smart, isn't it? However, there might be a situation where you don't have a highest compatible version. Just assume you have version 11 here and version 10.1 there. Now we have two different majors. And as we know, a major version is not necessarily backwards compatible. So it is a disaster. And to resolve this disaster, module federation loads both. Which is, of course, a little tiny hit on your bundle size. You need to download some additional bytes, but perhaps this does not matter. It really depends on your environment. Obviously, if we talk about something that needs to have a lot of conversions, a web shop, you need to measure this. Then this might be an issue. But if we talk about a business application that is used on a regular basis by your people, and if they have something like a browser cache, and if they don't have turned it off, then this won't be a big issue. So it really depends on your current context, on your architectural goals. But please keep this in mind. This will increase your bundle sizes a bit. But also we have lazy loading, so this is also something we need to consider. That means we might get the same version our application was compiled with. We might also get another version where we think this version is backwards compatible, 10.1 instead of 10. And getting a different version, a backwards compatible version, is very often a good thing. Just let me show you something. Yeah, the slide moved. It's very often a good thing. It very often works nicely in general. However, there is an issue. This issue is about internal framework APIs, something we normally not focus on because it's not our business. It's the business of the framework vendors, isn't it? But just assume a situation where you have a framework containing of two libraries, consisting of two libraries, namely A and B. And let's furthermore assume that A is using an internal API of B, an internal API. Very often, there are no guarantees for being backwards compatible with internal APIs. And so it might be an issue if we get another version of B at runtime, even though it's just another minor version. As there are no guarantees for internal APIs, this might be an issue. So please keep this in mind. And this issue also occurs if your framework comes with a compiler, which is quite common nowadays, isn't it? All the new frameworks have a compiler. In this case, A could also be your application. Because what happens if you compile your application with your framework compiler? In this case, the resulting source code might access internal APIs of your framework. Just after the compilation, you never touch it by hand directly, but after compilation, the compiled code does it. And this also might lead to a version mismatch because there are very often no guarantees for being backwards compatible with internal APIs. So please keep this in mind just to be on the safe side. If this is an issue for you, bin your dependencies. Don't use those special characters in your package JSON. If you don't use them, then Webpack module federation will not assume that this minor version is backwards compatible. No, just leave those special characters away. And one more time, Bob's your uncle. Okay, so there is another configuration option. You can tell module federation that this library is a singleton. And in this case, only one version can be loaded. So assume this micro frontend has version 11, another one has version 10.1. As the library is now a singleton, only one version can be loaded, and this will be the highest known one, which is obviously 11, 10 is not loaded. That means this micro frontend here gets version 11 instead of 10.1. Good luck. This might work, but there are no guarantees because it's another major version. No guarantees. If you are lucky, it might work. However, when such a situation is detected, it can only be detected at runtime because you are doing runtime integration. You get a warning on your console. It's like saying, hey, dude, this is not allowed officially, you know, perhaps it works anyway, perhaps we are lucky. If it does not work, perhaps we can tell someone that someone else wrote this source code, and so on. We just get a warning. If you don't want to have a warning, if you want to have immediately a slap into your face, then go with strict version. Set strict version to true, and this will immediately at startup give you a runtime error, an exception. And I really love this exception. It's about failing fast. This exception tells my integration tests quite quickly that something is going wrong. And yeah, this clearly shows you need integration tests. Of course, you need it in general, but here in such an environment, you need it especially, and you need to run them on your staging environment to find out if everything is fine. And this is for the very brave of you, the configuration from hell. This is about saying, well, I know this application was compiled against version 10, but trust me, I am an expert. It will run with everything between version 1 and 11. Yeah, perhaps you are right. Perhaps it works, but no guarantees. Don't blame Webpack if this dramatically fails. It's like casting in your source code. If you do a typecast, you are taking the responsibility. Don't blame the type system if something goes wrong. Okay, so as you have seen, Webpack really comes with several baked-in options. So it really does what it can do to deal with version mismatches. However, and I think you will agree with me, the best option is to avoid conflicts upfront. And for this, there are some additional strategies that cannot be implemented by a framework. They need to be implemented by yourself. One strategy is to just go with a mono repo. If you go with a mono repo, you can make sure that everyone is using the same version. You can force the same version on each and every team. This means that you are taking away a bit of the freedom you get by going with micro frontends, but you're also taking away a bit of the pain, a bit of the heavy parts. It's about restricting yourself so that you have less pain. And the other option is to go all in, to load several single page applications into your index.ts. You load several separate single page applications into your page, and they have a sharing nothing architecture. That means they don't share a thing. They bring their own dependencies, bring your own library, something like this. And of course, this increases the bundle size because now everyone needs to load their very own dependencies, but also it prevents issues with version mismatches. Everything is isolated and you don't need to concern what other bring in terms of dependencies. Of course, it's an increase for your bundle sizes. So you need to know your context, you need to know your architectural goals. In the last part of this presentation, I will show you a nice in-between solution, a nice solution that is in between those two options, that tries to achieve the best of both worlds. Yeah, and this last part of the presentation starts now. This is about combining several frameworks and versions of those frameworks. And as multi-framework, multi-version solution architectures is quite a long term, you know, in German, it would be one noun. I'm using a metaphor for it, namely the Frankenstein. And I think the Frankenstein metaphor is quite a nice metaphor because the Frankenstein worked, yeah. Dr. Frankenstein made this monster to live, to work. However, this guy is quite dangerous. We all remember how the story ended on the North Pole. It was not a happy ending. So there are several rocks on the road towards this solution. So what's the idea behind this? Well, the idea is a quite simple one. The idea is instead of loading components or other stuff from over there, we are loading a whole application from over there. We are wrapping this application into a web component, and then we are loading this huge web component, wrapping a React application, a Vue application, a Svelte application into our shell. And perhaps you've recognized that here I'm doing nothing with this imported web component. I'm not assigning it to a variable. I'm doing this on purpose because a web component is technically a side effect, isn't it? Below the web component, it's registered with the browser, and suddenly the browser knows new tags. And when we use those tags in our page, those elements, the browser will render this or that web component. So just load it and, you know, Bob's your uncle. Normally, a web component is mounted in an element. That means somehow we need to add this element to our page. We can do this with this 20-year-old DOM magic. And then immediately the browser will render the web component in there. And last but not least, somehow we need to route to this separately bootstrapped single page application. And most routers I know of are not capable of routing to another application. So we need to wrap this source code into a wrapper component. You need to write it with your framework of choice, Angular, React, Vue, something like this. And this means your router can activate this wrapper component, and the wrapper component does the rest. Adding an element, loading the web component, making the browser to render the web component in the middle of your application. Of course, there are some workarounds you need to go with when it comes to this. You know the proverb, never ever look into the sausage factory. And that's why I've hidden some of those workarounds in this library. You can use it as is, or you can look up the source code and adopt it for your needs. However, if you go down this rocky road, then you have the best of both worlds. It's really beautiful. Then you really get the best of both worlds. Namely, you can have different versions, even different frameworks, because you are bootstrapping all the applications separately. plus the details are hidden behind the web component. The browser is not concerned about the very version. It's hidden behind the web component. However, as we also add module federation to our architecture, we can share libraries if two or more micro frontends need to go with the same version of this very library. If they need a different version, yeah, bring your own library. Best of both worlds. Let me show you all of this in practice. For this, let me go into my routing configuration. I've already prepared another routing configuration item. This is a very convenient way of programming, just copying in source code. I really like this. So what we get here is another route. The route is called React, and it points to this wrapper component, which is just a simple tiny component that is loading a web component via module federation. And for this, there is some configuration data. There is the configuration data we need for module federation. Most of those entries are the entries you have already seen before. The location of the metadata file, of the remote entry file, a remote name, how it's called over there, and the exposed module that gives us the web component in question. And then I'm also passing in the element name. And now this web component is loaded. We are getting an element with this name here. And so the browser will render the web component directly in here. And that's it. As you have seen here, I've deployed this React-based web component on an Azure website. Azure Static Apps, a nice solution for dealing with such static single-page applications, by the way. Okay, let's try it out. Let me click here on Surprise, and hey, it really works. Now I'm running a React application in the middle of my Angular application. Plus, if someone else needs the same React version, it's shared. I have a bit more for you. I have another example. It's a bit more elaborated. It runs in the cloud. And here we see I have an Angular shell. Here I'm loading a micro frontend using the same Angular version. I'm using a React micro frontend. I'm using a micro frontend using a different Angular version. But this different Angular version is only loaded once and shared across all the other micro frontends needing the very same version. Here I have Vue. Here I have Angular.js. I think that really shows that this architecture is also a nice approach if you want to migrate away from a legacy stack, especially if you can slice your application system vertically. And here I have a dashboard using everything together. I would really try hard to avoid such a use case, because for this use case, we need to load all those frameworks immediately, which is very likely not the best thing for your performance. So if somehow possible, prevent a situation like this, especially if it is a performance critical solution, a public solution where conversion rates are important. If we talk about internal business applications, very often there are different rules. Okay. So if you like this presentation, you might also like this book here. It's my free ebook. It's meanwhile in the 5th edition. And this ebook contains a lot of stuff of module federation and related topics like domain-driven design, strategic design for the Angular world. So if you like this talk, download this ebook. If you did not like this talk, download it anyway. Perhaps I'm better at writing than at speaking. Who knows? Let me come to a conclusion. We have seen that all of this is about loading separately compiled and deployed code and about sharing libraries. And module federation is really great when it comes to this. It even comes with several baked-in strategies for dealing with version mismatches. Plus, we can instrument Webpack module federation at runtime. We can tell it at runtime about the available micro frontends, which is the key for very dynamic scenarios. And last but not least, you can accomplish a Frankenstein by combining everything with web components, and so you get the best of both worlds. However, it's a bit a rocky road. It's doable, but the road is a bit rocky. Besides this, none of the frameworks out there are officially tested together with other frameworks in the same browser window, or with other versions of itself in the same browser window. And this is another reason why this road might be a bit rocky. Nevertheless, it's doable. Okay, that's it. So here you'll find my contact data. I've already uploaded my slides and examples to my blog, and follow me on Twitter to keep in contact. Thanks for having me.